Hey, today we are talking about the structure of our atmosphere. And before we really can have a discussion about weather, we have to know a couple of basic things. We've already talked about air masses, and the next kind of basic information we need to know is just simply the structure of our atmosphere. Weather occurs in our atmosphere, so we should have some understanding of the atmosphere and where this weather is taking place. And the first thing with our atmosphere we have to talk about is just air pressure. And we're going to talk a lot more about air pressure later, but for now, when we talk about the structure of our atmosphere, we just have to know what happens to air pressure when you go from sea level to outer space. And it's a very easy trend. Air pressure is constantly decreasing as you go closer to outer space. So at sea level, the air pressure is greater than if you were to walk to the top of Mount Everest. And one way to think about air pressure is just thinking about a column of air above your head. So if you just look straight up at the sky, all of the air molecules you're looking through would be kind of considered a column of air sitting above your head. And if we count up the mass of all of those molecules that you're staring straight through all the way to outer space, they all have combined, they have weight. And the weight of those molecules pressing down on the top of your head is one way to think about air pressure. So again, at sea level, looking up at the sky, that column of air is much thicker, it's much taller, and it contains a lot more molecules. So it's going to be very heavy compared to the column of air if you go to the top of Mount Everest, which would be really cool to do someday. And if you look up through the molecules, through the atmosphere to outer space on the top of Mount Everest, that column of air is much, much shorter, meaning it contains less molecules and therefore has a lower weight. So at the top of Mount Everest, the air pressure is a lot lower. Besides air pressure, we also have to know what happens to temperature as we go from the surface of Earth to outer space. And this one's not as easy. It's not an easy trend or pattern like we had with our air pressure. So please make sure you're filling in the diagram, the graph, in your notes. And we're going to start at the surface and work our way up to space. So starting at the surface of Earth, where we live in the troposphere. And you probably know the temperature change that takes place where we live, what we're familiar with. Because you know if you go up in elevation, if you hike to the top of a mountain, you better bring a sweatshirt or a jacket, because the temperatures, the higher up you go, are always lower. And that's the trend that we see here in the troposphere. Temperatures are always decreasing. And they decrease to an elevation that we call the tropopause. And this is where temperatures are neither increasing or decreasing. Things are kind of just stagnant. They're stationary. No increase or decrease. That's the tropopause. And the tropopause is followed by the stratosphere. And this is a layer, and this might be a little crazy to say, but it's a layer of temperature increase. The temperatures are getting warmer in this layer of the atmosphere. And there's a very specific reason why the temperatures are getting warmer. And it's all about that fuzzy little line. It's the ozone layer. Ozone is a chemical of oxygen. It's O3. And what ozone does in the atmosphere is it kind of collects in and prevents ultraviolet radiation from getting to the surface. So that UV light, it hits ozone, O3, and it breaks apart into a single oxygen and a O2. And over time, that double oxygen, the single oxygen, they pair back together and they reform O3. But every time that molecule is broken, it releases heat. And since we're having this heat release in the stratosphere, it warms it up. So the stratosphere is a layer of temperature increase. And it's followed by another pause, the stratopause. And this is again where there's not an increase or decrease in temperature, it's just kind of the same as you go up. And the stratopause is followed by the mesosphere. Now the mesosphere again is a layer of temperature decrease, and this is the coldest layer in the atmosphere. And so as you go up and up, the temperature goes down and down and gets very cold until you get to the mesopause, which again is a layer of neither increasing or decreasing. And that brings us to the last layer we're going to talk about, which is the thermosphere. And this part might blow your mind. And it's that the thermosphere is a layer of Earth with a constant temperature increase. Now check out that graph. Look at it. Look at it right now. Look at that red line. It goes off the charts high, like much higher than it is here in the troposphere. The temperature's off the chart. But this is the tricky thing, and this is the cool science here, is that this whole time I've been talking about temperatures. I haven't really been talking about heat. And that's just because in chemistry and in science, heat and temperature are two different things. The temperature of a molecule is kind of like the potential energy it's containing, and it has available to transfer to another molecule when they collide, when they touch. and heat is the actual transfer of that energy. So down here in the troposphere, the temperature is really high, but there's also very high heat. And that's because there are molecules everywhere. These molecules that have a high temperature are in constant contact with our skin, and they're transferring that energy they have to our skin, and that's why it feels warm. That's heat, that transfer of energy. When you go up to the thermosphere, there are very few molecules present. Each one of those molecules might have a very high temperature, but there's no other objects up there to transfer that temperature, that energy to. So although I'm saying it's a very high temperature, it's actually a very low heat. It's freezing. One molecule may have to travel something like an entire kilometer just to bump into one other molecule and have some heat transfer that way. So I just think that is so amazing that, yes, the thermosphere in outer space has very, very high temperatures sometimes, but a very, very low heat. Make sure you look back through your notes and make sure you have a really good diagram drawn here. You're gonna thank yourself later. If you have questions, make sure to ask. Otherwise, thanks.